of weeks, we've been doing a lot of work with multiplication, and I feel like you guys have a pretty good idea of what that looks like. If I ask you to solve a multiplication equation, I know that you can use counters to do that, or I know that you could use a picture to do that. I feel like you guys got a good idea about multiplication. Division we haven't spent as long with. We're going to kind of bounce back and re-talk about division. So some of this you might know, and that's okay. And some of it you might be hearing again and being like, oh yeah, I remember talking about that. There are two symbols that we see in division. We might see this symbol. That symbol shows up a lot, especially when we're writing. But I don't have that symbol on my computer. And so sometimes you'll see division, especially if I have to type it, that looks like that. It's like a slash. So take out your math notebook, please. Thank you. Take out your math notebook. It is blue. When we see those symbols, or when I'm talking about division, what does that mean I'm going to be doing? If I'm dividing something, what does that actually mean? Dylan, what does that mean?
You're dividing something.
I am dividing something. Okay, so again, we've got that group, so that's a key piece. Maverick, you want to add on to that?
It's like you have a number and then you divide it into like certain numbers.
Okay, David, you want to add on to that? Connor, stop doing that, please.
It's where you where there's like a number and you put it into groups.
Yeah, we're putting things into groups. Avery, you want to add on to that?
Maybe division is something that people use to sometimes, let's say your friend wants, let's say you have 10 apples and you want to divide them into equal groups, 5 and 5. That's kind of dividing into equal groups.
I love that. So I heard two things. I heard that we are breaking apart a number, which is definitely true. We would break it apart. Go on, you got a question, friend? Normally, we don't hear the words breaking apart a number in real life. No one says break apart this number. But they do say this word.
Divide.
Share. If you're sharing something, you're breaking however many things you have and putting them into groups. So even though we don't hear someone say, hey, break this number up, they might say, hey, share this stuff. That means you're going to be putting it into those equal groups. Into, and you guys talked about, I heard a lot of good definitions using the word equal and using the word groups. That's definitely a very big part of division, being able to make sure we've got stuff being put into those equal groups. All right, we're writing, friends. One thing with division that is kind of tricky, because we've been talking a lot about multiplication. When we are multiplying something and we're trying to figure out the total, we don't know the total when we're multiplying. I might say, here are 5 bags, and in each bag are 6 things. How many things? I don't know the total. That's why I had to multiply to figure it out. But with division, I already have all the stuff. So Callie's got, I don't know, Callie, she got a lot of socks.
I love it.
A lot of fidgets. Callie got a lot of fidgets. If she's going to be dividing or sharing, Callie, when you share, do you get more fidgets?
No.
No, you take what you have and then you share out. You're not getting any more. You're just taking what you have and making it look different. So in division, we have the total. You're not getting any more of the things. I'm writing, that means you're writing. So if I'm dividing out socks, or if I'm dividing out donuts, or if I'm dividing out Halloween candy, I'm not getting any more. I've got it all. That total is all there. Then I'm sharing from that total.
Oh, I can smell my flame.
Oh, no big deal. You do not need to write this problem down.
I did it. Your first is the
You don't have to write that problem down. But I want you to think, what are we counting in this problem? We still need an answer sentence. I'm going to read it to you. Follow along with me so that you can figure out what are we counting. There are 12 sticks of gum in a pack. You want to share the gum equally among 3 people. How many sticks of gum will each person get? Read that problem again. Think about, what am I counting? So I don't care what the answer is. I want to know what we're counting. That's the question I'm asking. Ava, what am I counting?
We are counting sticks of gum.
I am not counting sticks of gum. I already know how many sticks of gum I have. That's why this is tricky.
I know.
Addison, what are we counting?
We're trying to count how many gum it takes to split between among 3 people.
Not quite. You're close. Callie, what do you think?
How many packs of gum?
Not how many packs of gum. Nope. Let's look carefully at this question. How many sticks of gum will each person get? Jordan, what are we counting? I am not counting people. I know how many people there are. Bowen, you think you know?
How many are we going to share to the people?
How many you're sharing? The key word here
How many are in the group?
is each. Whoever said sticks of gum, I don't remember who said sticks of gum. You were so close. It's not sticks of gum total, but sticks of gum to each person. So let's write our answer sentence. Connor, you think you can help me?
In the group?
All right, Connor is starting out with that word each. I think that's a great strategy. Each person.
God, are we writing it?
Each person will get blank sticks of gum. The key part here is exactly what Connor started us out with. Each. I'm not just saying there's so many sticks of gum. I already know that. It tells me that in the first sentence. I do need to figure out how many is each person getting.
Like it's showing me that you're stuck wrong.
It does kind of look like that, doesn't it? We're going to draw a model. I like a bar model, so we're going to do that today. Even though you know there's so many different models you can use. Let's draw a bar. And then another bar that's exactly the same length. When 2 bars are exactly the same length, that tells me they are equal. They're the same length. I know that they're equal.
But the same length.
Yes, same width, same, as much of the same as you can, go on. That bottom bar is going to be our total. Maverick, what's that? No. What's the total amount of gum? It tells you in the problem. It's not something that you have to come up with. It's the total amount of gum. Samaya? 12 what? 12 sticks, right? Yeah. So I'm going to write 12. Am I getting any more gum?
No. You're getting it all.
No, I'm not getting any more gum. 12 is what I got. Can you imagine putting 12 pieces in front of you? 12 pieces right in front of you. Now what you're going to do is I have to share. There's that word share that's telling me I need to be making some groups. How many people am I trying to share with in this problem? Cole? 3. So in that top bar, I'm going to make 3 boxes. Penelope, why did I make 3 boxes? Those are my 3 people. Those are my 3 people. Now, we learned a strategy called the dealing out strategy. Does anyone remember what the dealing out strategy is? Archer, you remember?
So you give them one piece until you get to the number 12.
Yeah, we just kind of give them 1 piece each until I get to my total. I kind of jumped ahead. I got too excited. I wanted to solve that problem. What's the equation that matches that picture right there? If you're having trouble, think back to part, whole. Maverick, can you give me an equation?
12 divided by 3 equals blank.
We have 12 things. We know that division symbol means to put into groups or to share into groups. 12 shared in 3 groups equals box. I'm sure some of you can figure that out, but that's fine. Can I write another equation? Can I write another equation?
Yes.
Callie?
12 divided by box equals 3.
I can do that. I can say 12, giving out my each individual pieces gives me 3 groups. That'll work. Is there another equation I can? Marley?
You could do 3 divided by 12 equals blank.
Do I have 3 things?
No.
Oh, how many things do I have?
12.
I have 12 things. So I have to start with my total things with division. I can't start with 3 and then give everybody 12. Will that work?
No.
No, we got to start with 12.
12 divided by...
Think of it as times.
You can think of it as times. How could you make this a times equation? We have the
You could
pieces.
just flip it around.
All right, Bowen, give me a times equation because it seems like you got one in your brain.
3 times
3 groups of
Blank.
box.
equals 12.
Ooh, I have 3 groups of something is worth 12. What about this equation? Ready? Something times 3
equals 12.
equals 12. Could I do that?
Yes.
And
I know what the answer is.
Could I do box plus box plus box equals 12?
No.
Yes.
Yeah, that will work. Is that probably the best strategy?
No. You won't know what it is.
All right, now we're going to zoom back to what Archer said about our dealing out strategy. You ready, Archer? 1 for you, 1 for you, 1 for you. How many have I used?
3.
3. Is my top bar equal with my bottom bar yet?
No.
No. My top bar has 3, my bottom bar has 12. They're not equal yet.
I know.
I need to keep going. 1 for you, 1 for you, 1 for you.
Oh, that looks like an
Are they even yet?
No.
All right, how many have I dealt out so far?
6.
6. That one looks kind of crazy, doesn't it?
Yeah, it looks like an L.
Is my top bar equal to my bottom bar? Nope. So I'm gonna keep going. I'm at 6. Is it equal yet? No.
Yeah. That looks like an L.
So is my top bar equal to my bottom bar?
Yes.
Does my top bar look like my bottom bar?
No.
Is that okay?
Yes.
Yeah.
Just because it looks different doesn't mean that it's actually different.
Yes. Say it again for the friends in the back.
Just because it looks different doesn't mean that it's actually different.
All right, you ready? We're going to do an epic high five, air high five. It's going to be a 2 double-handed air five and 2 foot fives at the same time. You ready?
Y'all are gonna jump.
Set. Go. No, you missed a foot. Ready, set, go. Got it. Yes. Just because it looks different doesn't mean my value is different. It's still worth the same amount, even though one of them split up into 3 groups and one of them's all together. What's my answer to this problem?
Oh, I got it.
Because we did the dealing out, just like Archer said, we made some equations. But now we gotta finish that answer sentence. Mason, what are you thinking? Each person will get
4 pieces.
4 sticks of gum. Mason, how did you know it was 4? Because I got a lot of numbers on this page.
So what I did, I know that 3 plus 3 is 6. Okay? And I know another 3 plus 3 is 6. So there's 2 3s and 6.
Mm-hmm.
That makes it 6 that it is.
Mm-hmm.
And 3 plus 3 is 6. So count those. There's your equation.
Mason, hang on to that strategy, because we're going to talk about that strategy that you're talking about right now. But just looking at my picture, how would you know that it was 4?
Because 4 plus 4 plus 4 is 12.
Where is 4 on this picture? Because I didn't even write the number 4.
It is
In my dealing out strategy, I know it's 4 because right here, I have 4 sticks of gum for you, 4 sticks of gum for you, 4 sticks of gum for you. Alright, so today we're going to talk about a slightly different strategy. If you like dealing out strategy and that's your go-to, awesome. I'm going to show you a new strategy. We're going to practice it today, but moving forward, if you want to go back to dealing out, that's fine. Okay? How does it work?
called community property.
What is called community property?
And when it looks different, but it's actually the same.
Not always, but I know what you're talking about. It's kind of similar to community property. We can switch those factors, and our total doesn't change. Good connection. All right, so what we're going to do now is we're going to be comparing 2 different strategies. So I want you to turn to the next blank page, because this is going to take a lot. Your title is going to be Division Strategy, and you're going to make a T-chart, and you can go all the way down the page. It looks like a giant T. One side is going to be our strategy that we know and love called dealing out. And then the other strategy that we're going to talk about is what Mason was kind of talking about earlier. It's called repeated subtraction, which sounds kind of creepy. But I think when we look at it, we're going to see those strategies are actually pretty similar. But go ahead and get your notebook set up so that we're ready to talk about them. So what we're going to do to solve this problem is we're going to do an equation at the same time.
What?
It's going to make sense, I promise. So underneath both columns, we're going to look at the equation 16 divided by 4 equals box. So you're going to write that equation under each section. Because we're going to do the same equation, we're just going to use 2 different strategies. So everything that's on my board has to be in your notebook, friend.
Do we write it at the bottom ones too?
Alright, our first strategy, we know exactly what it should look like. We're going to draw our bar. We know that the bottom bar is our total. Our total number in this problem is what? What is our total amount of stuff in that equation? Ava, what is it?
16.
16. We're not getting any more things. That's why that's written right there. Connor, sit up, please.
We need 4 little columns.
I know that that next number 4 tells me I need 4 boxes.
How many times does 4 fit into that? How many times does 4
And
go
then
into
we
16?
know that that we could go 1 for you, 1 for you, 1 for you, 1 for you. Go ahead and deal out just like you know how to.
So you put 4 in each.
Go ahead and deal out just like you know how to. 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16.
Is 16 an even or odd number?
When I make partners with 16, it's going to always have a buddy. So if it always has a buddy, is it even or odd? Even. A good trick, Mason, for bigger numbers is to look in the ones place. That number 6 is an even number, which means that whole number will be even.
So 6 is odd.
No, 6 is not odd.
6 is even.
All right, now we're going to go over to my repeated subtraction problem. In order for this to make sense to see it in your brain, what I need you to do is to draw 16 circles. Don't make them giant. I'm going to kind of make mine in an array just to make it easier for my brain.
Columns and rows.
2, 4, 6, 8, 10, 12, So I'm going to imagine those are all 16 of my things. 16 cups of coffee. I'm not sure. And I know that second number, Colby, that tells me, hey, I need 4 groups. So what I'm going to do is I'm going to circle 4 of them. Circle 4 of them. I'm going to take that group away. Now, I'm not going to mark on it, but imagine in your brain, you just threw those boxes away, or those dots away, those cups of coffee away. So what you just did is you did 16 minus 4. You took a group of 4 and you moved it away. When I did that, how many things did I have left? I had 16 of them. I got 4 of them because I'm making groups of 4. And I moved it out of the way. So how many do I have left, Emma?
12.
12 things.
I knew it.
Is there any confusion about what just happened?
No.
We're good here.
No. It's just.
Okay. Did I use all my things though?
No.
So I'm going to now make another group of 4.
Take it.
But remember, this group of 4 didn't exist yet. So I had 12.
Then you took 4 away.
And then I took another 4 away because I made another group of 4. So I had 12. I made another group of 4 and moved that out of the way. Where am I at right now? Addison?
You're at 8 now.
I now have 8 things.
Because if you take away 2 from the 4, then you have 10.
Beautiful strategy, Addison. Beautiful. How many groups have I made so far?
2.
I've made 2 groups. Did I share all my things yet?
No.
Nope. Let's make another group of 4. Did I have 12 things when I made that group of 4?
No.
No, I only had 8 things. And then I made another group of 4. If I took that group of 4 and I moved it out of the way, how many am I left with? I had 8 things. I made a group of 4, moved it out of the way. Colby? I have 4 things left now.
If you have 8 plus 8, if you do 8 minus 4, that would equal 8.
Did I share all my things?
No.
No, I still got 1 more group.
This is equal 0.
All right, I had 4 things. And then I made a group of 4 and got rid of it. How many things do I have now?
0.
Good. I should have 0. The reason why I should have 0 is because I shared all my things. Now, Bowen, I know you like to take time to harass me on my letter formation and my number formation. I want to explain something to you.
I'm not going to.
The reason why I put this line through my 0 is because sometimes zeros look like the letter O, but O's don't have lines through it. So that's why I do that, okay? I'm just explaining it.
Yeah, that's what I was asking.
How many groups did I make? Maverick, how many groups did I make? 4. And I can see it right here, see? Here's one group of 4, circle it. Here's one group of 4. Here's one group of 4. And here's one group of 4. Art, you're circling from.
What about this one?
So this tells me if I have 16 things and I want 4 in each group, how many groups do I get? Well, we just figured it out.
4.
That new strategy we just looked at is called repeated subtraction. Why do you think it's called that? Avery, what do you think that?
Maybe because every time it goes down, there's always, see how the 4s are the 4, it's repeating. It's 4, 4, 4, so maybe that's why, because all the equations are repeating.
Yeah, Gnarly, what do you notice?
Maybe because if you had that 8 right there and 12 minus 4 equals 8, you would have that 8 down there.
Okay. This is very similar to repeated addition. Do you remember when we were doing repeated addition with multiplication?
Yeah.
And we added up the same thing?
Yeah, it's just different because we added up, but this one we're going down.
Now we're going backwards. So with multiplication, we had to add it all up because we had to figure out our total.
Yeah.
But with division, we have our total. We're now going backwards. All right, we're gonna try another one. I want you to practice repeated subtraction on this strategy. We're gonna do it together. Bowen, what's up?
Multiplication is just backwards. Just backwards. Fine. Backwards multiplication.
Multiplication is backwards division. Is that what you were trying to say? Can I give you some math words to use because the idea is correct? So in math, instead of saying it's backwards, we say it's inverse. Inverse means it's opposite. You're exactly right. It feels like it's going backwards because it's the opposite.
Wait, it's opposite.
All right, we are going to be writing this equation. Now look at that symbol. What did I tell you that symbol was? Samaya? Division. Now remember, I don't have that division equation, or sorry, division symbol on my computer. So when I type it, you'll see this symbol. Go ahead and write. If you need to turn the page, that's okay. Go ahead and write this equation. We're going to do 24 divided by 6. If you need to, you probably need to. You can decide. It's your notebook, love. Alright, so we're going to think of this as our repeated subtraction. I'm going to go ahead and draw my total. I'm drawing 24 dots.
I could have done it as loud as a turbocharged VA. Twin turbo.
Get your 24 dots down. So this is the time where you're writing 24 dots. Mason, we're writing 24 dots, please.
Oh, come on.
We're doing 24 dots today, just so you can see where these are coming from. In the future, if you already know where it's coming from, you don't have to draw the dots. All right, so the first part of my equation says 24. Here is 24. We have that total. That next piece tells me I'm making groups. What number, or how many should I say, are going to be in each group? That's what that next number tells me. 24 put into, this number is going to tell me how many go in my groups. How many go in my groups? Jordan? with 24. I made a group of 6, and now I'm going to get rid of it. I'm going to push it to the side. When we get rid of something, we use what operation? When I get rid of something, what math operation am I using, Maverick?
Subtraction.
Subtraction. Getting rid of my 6. How many dots will I have left? How many things will I have left? I've made one of those groups. I put it to the side. Now what?
How do you
Cole, how many we got left?
18.
So far, so good?
Yep. Yeah.
Colby, you good? You have 18 dots?
Why can't we just circle groups of 4?
Because this tells us that we're making groups of 6. Let's make another group of 6.
I can make another group of 6.
Now, Connor, we already got rid of this group. But how many did we have left? We had 18. And then what did we do?
Minus 6 equals 12.
We made another group of 6 and got rid of it. And that left us with how many dots now?
12.
Well, very good. This is the math language for that. We had 18 things.
That's 81.
No, thank you. We made a group of 6, and that subtraction tells us we got rid of it. Got rid of it. How many dots do I have now? Accents?
But you have it on
You're
your
doing something. I have 12. They're right here. I have 12. What am I going to do now, Paxton? I'm going to make another group of 6. Here's my group of 6. What am I going to do with that group of 6? I'm going to get rid of it. There's my symbol to get rid of it. I have 12 things. Get rid of 6 things. How many will I have left when I do that? 6. I will have 6. Marley, how many things do I have now? I have 6 things. What am I going to do with those 6 things?
You give it to someone and then you have nothing.
I'm going to give away those 6.
Minus 6 equals
I
6.
have nothing.
No, 0. That's 6.
The hard part of repeated subtraction is figuring out how many groups you made. Here's a strategy I like to do. I didn't do it on the last one, but here's a good strategy. When I go back and count my groups, I'm going to include that minus sign. Because I knew when I was subtracting, I was getting rid of a group. So circle minus 6. There's one of my groups. Then I did another minus 6. There's another one of my groups.
It's 4.
Then I did another minus 6. There's another one of my groups. Then I did another minus 6.
4 minus
So
6.
Bowen, how many minus 6, how many groups did I make and then get rid of?
4.
4 groups. That's what that is asking me. 24 things put into groups of 6 equals how many groups?
4.
4 groups. 4 groups. Two is we've got one last story problem we're going to look at. One last story problem we're going to look at. You probably have room. If not, turn the page. You can decide. It's your notebook. We're going to look at this last story problem together. I will let you choose what strategy you want to use. So Archer is selling cookies. Way to go, Archer. He made 72 cookies.
What?
For his next sale. Wow, that's a lot of cookies, Archer. You must be really busy, huh?
Yeah, he's a busy man.
All right, he has 8 different flavors of cookies. Pause. You know what I'm wondering right now? I'm wondering what those flavors are. Say. All right, friends. So he has 8 different flavors of cookies. If he has an equal number of each flavored cookie, That means if you've got chocolate chip, you've got the same number of chocolate chip as he does snickerdoodle, as he does sugar, as he does oatmeal raisin. The same number.
As he does
How
caramel.
many cookies of each flavor does he have? Now we're going to do something that we haven't done before. Read that problem again. Read that problem again in your head. Cole, what are we counting? That's not specific. That's not specific enough.
The flavors of the cookies.
I already know how many flavors he's got. That's why this is tricky. Jackson, you want to try? This is a hard one.
How many he's selling?
I already know how many he's selling. Avery, you want to try?
Yeah. He is wondering how he could put what flavors there are so he can put them into equal groups.
Oh, I turned the page.
Archer, what do you think?
Pretty sure we're counting how many cookie flavors go in like each.
Alright, so you've got the right words, they're not in the right order. I heard Archer use the word each. That is important. But we're not figuring out cookie flavors each. We're figuring out how many cookies are each flavor. So I might say each flavor has blank cookies. Each flavor has blank cookies. Now we're going to think about this problem in a way that we have not done so yet. We've got 72 cookies. And we know that he made 8 different flavors. What would be a really bad answer for the number of cookies each flavor has? We haven't thought about that before, but we are purposely going to think about the wrong answer. What would be a really bad answer to this problem? It doesn't make sense. Emma? 1. Why is 1 a really bad answer?
Because they're selling 72 cookies.
He's got 72 cookies. Would it make sense that he only has 1 of each flavor? No. 1 is a really bad answer. What else could be a really bad answer? Ava?
1,000.
1,000. Why is 1,000, Ava? Why is 1,000 a really bad answer?
Because it's like super high, and this is only 72.
Yeah, it doesn't make sense that he has 1,000 of each flavor if we know he only has 72. Maverick, I need the noise to stop from your hand. Alright, Maverick, what else could be a bad answer?
8 million?
8 million. Would be way too big. Allie, what else would be a bad answer?
100 billion?
100 billion. Let me ask this question. You ready? Don't yell at me, just raise your hand. Tell me. Do you think 72 is a good answer or a bad answer? Raise your hand and tell me. Do we think that's going to be a good answer or a bad answer? 72. Paxton, what do you think?
Bad answer.
Why do you think 72 is a bad answer?
Because there's 8 flavors on the set.
I only have 72 cookies.
That'd be like
If I have 72 of each flavor, is that going to be even possible? No.
That'll be like 100.
Alright, let's draw our box. Draw our model. We are always going to draw a model, even if you choose a different strategy.
Even if you choose,
Even if you choose a different strategy, we're going to draw our model. We're going to make 2 bars. I know that my total number of cookies is not going to change. Alright, so how many total cookies did you make? 72. Are you making any more in this story? No. 72. We're not changing that. But we have some different categories. Alright, how many categories did we have in this problem? How many? 8. I'm going to draw 8 boxes. Each of my boxes will stand for my different categories.
Is that 8?
There are 8 boxes because Archer made 8 different flavors. What equation matches that model? What equation matches that model? Marley?
Let me think. 72 divided by 8.
72 put into 8 groups
Equals box.
equals box. We now know 100% it's a division equation. I want you to choose either dealing out or repeated subtraction. Whatever makes your brain happy. Once you have solved it, then you know how many of each flavor. Give me that secret thumb. I saw a lot of dealing out, which is a great strategy, but there was a lot to deal out.
72.
It didn't work. So I just want to show you what repeated subtraction might look like for one like this.
It didn't work.
I don't have to draw my dots because I know there's 72 of them. Right, Ava? Do you know there's 72?
Yes.
Yeah. I know you did, and it's fine. It's not going to hurt you. But now next time, do I have to draw them all out?
No.
No, because now you know. And I'm making a group of 8. That's what that means. And I'm getting rid of it. Bowen, do you think you can figure out what 72 minus 8 is?
72 minus 8. 80?
We're going backwards. So it's not going to be in the 80s.
It's minus
8. I said 8.
72 minus 8 is not 8.
No, 4. 4.
If I count backwards, I get to
63.
no 64.
Dang, I counted. I was doing my hands.
Colby, you with me? 64 minus another group of 8. If I count backwards,
Oh,
56.
well, then
I have 56. I make another group of 8.
I was right. The 1 for 4.
The ones were 4, but you didn't say those words, so I wasn't sure what you were talking about. Maverick, if I had 56, then I'd take away group of 8.
48.
48, turn it off. And sit down. You're not touching things. You can walk around, but we're not touching things. Alright, I got 48. Minus a group of 8. Well, that one's not complicated.
48 minus 8.
40.
Oh. Marley?
8. No, 40.
40. There we go.
40. Come on.
Now I got 40. Minus 8. That one's a little trickier. 40 minus 8. How much?
32.
32. Now I've got 32. Minus another group of 8. That one's tricky. Cool.
What?
Do you have 32 minus 8? Oh. Okay.
Twenty-four.
24, great job. Got 24. Minus a group of 8. No, thank you. Oh, no, thank you. 4 minus a group of 8? Archer, you figured it out? Very close. 16 minus a group of 8. Mason, you got it? 16 minus a group of 8.
I'm like halfway off the page. It's 10 minutes.
You're really close. How do you hold them out? 8. Number 8 plus 8. Alright, and I'm almost done. 8 minus a group of 8. 0. Now I go back. And I find all my minus 8s because those are all my groups. Here's 1. 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 Whoa. That's a lot of groups. When you were dealing out, you probably had a lot of tally marks.
But I can't put them in equal groups.
We can. We just did it. We made equal groups because all of those have 8 groups. That's why we subtracted them. And we got all the way down to 0. That's how we know they're equal. Callie?
So that means if you were to do another equation in there, say there was all 2 in each, and there was like 1. Isn't it 9?
It is 9. I had 9 little groups of 8. If you dealt out, you should have 9 tally marks. That was a really hard one because that was a lot of math. All right, friends. So we are going to stop here. Tonight for homework, if you get to the point, especially on that repeated subtraction problem, that you need help, where could you go for help? Home. You could. I can almost guarantee that your parents did not learn the repeated subtraction strategy. So they might not know, is what I'm saying. They know how to divide, but they might not know that strategy. You have another solution?
Texting on the computer.
You can use Clever. Now, sometimes I don't ever always get those messages right away, but you can use Clever messages. Is there another place where you could like see this happen? Paxton? Oh! Go to math videos. This lesson is about to be there. So tonight for homework, if you're like, oh, I don't really remember, go to my website, go to math videos. It's there. It can help you. Callie?